Okay, so picking up where we left off, in the inner ear and the cochlear duct, we are going to have the organ of Corti. And the organ of Corti is going to have 3 rows of outer hair cells and 1 row of inner hair cells. The inner hair cells are going to be the only hair cells that are innervated by the peripheral processes of the bipolar spiral ganglion. So the axons of the spiral ganglion are going to form the cochlear nerve, which are going to meet up with the vestibular nerve to form the vestibular cochlear nerve, or cranial nerve 8. So the vestibular cochlear nerve is going to travel through the internal auditory meatus to get to the posterior cranial fossa, and then it will enter the brainstem at the cerebellar-pontine angle. Once it enters the pons, the first order neuron of the cochlear nerve is going to bifurcate to synapse at the ventral cochlear nuclei and the dorsal cochlear nuclei. And Dr. Smith points out in the course pack that the DCN and the VCN are both tonotopically organized so that high-pitched tones are going to be heard in the more posterior or dorsal regions, and low tones are going to be heard more in the anterior regions. So the DCN and the VCN are going to contain the second order cell bodies in the auditory pathway. So the second order neurons from the ventral cochlear nuclei are going to project bilaterally to the ipsilateral superior olivary nucleus and the contralateral superior olivary nucleus. So these are going to contain the third order cell bodies in the auditory pathway. These fibers are going to be called the ventral acoustic stria. The fibers that are crossing to the contralateral superior olivary nucleus are going to cross anterior to the medial lemniscus. Other axons from the ventral cochlear nuclei will travel anterior to the medial lemniscus to form the lateral lemniscus, which will synapse at the inferior colliculus that is on the contralateral side to the ventral cochlear nuclei. The superior olivary nuclei will also innervate the contralateral superior olivary nuclei. Therefore, you can see that the superior olivary nucleus will receive information from its ipsilateral ventral cochlear nuclei, its contralateral ventral cochlear nuclei, and its contralateral superior olivary nuclei. The fibers that are passing anterior to the medial lemniscus, so this includes second order fibers from the ventral cochlear nuclei and third order fibers from the superior olivary nucleus. These fibers are called the trapezoid body. Lastly, I just want to point out that the superior olivary nucleus is going to receive that binaural auditory input from the ipsilateral ventral cochlear nuclei as well as the contralateral ventral cochlear nuclei, which I did not illustrate, and it's going to project fibers through an ipsilateral lateral lemniscus. And again, the fibers in the lateral lemniscus are going to synapse at the inferior colliculus. So far we have fibers projecting from the ventral cochlear nuclei to the contralateral lateral lemniscus to synapse in the inferior colliculus, as well as superior olivary nuclei fibers projecting through an ipsilateral lateral lemniscus to the inferior colliculus. So now we're going to add in the projections from the dorsocochlear nuclei. The dorsal cochlear nuclei are going to project their second order fibers anterior to the MLF to the contralateral lateral lemniscus to synapse at the inferior colliculus. So I didn't illustrate this on both sides just because it would get a little bit crazy, but at this point now the lateral lemniscus will have second order fibers from the contralateral DCN and the VCN, because the VCN projects contralateral fibers to the lateral lemniscus. And it's also going to have ipsilateral fibers from the third order neurons of the superior olivary nucleus. So I just didn't show that on this side. So in the simplified version of this pathway, the inferior colliculus is going to contain fourth order fibers in the auditory pathway. And these fibers from the dorsal cochlear nuclei that are projecting anterior to the MLF, these are going to be called the dorsal acoustic stria. So going back to the inferior colliculus, we know the inferior colliculus is going to be in the midbrain, and it's going to function mostly as a brainstem auditory relay nucleus between the cochlea and the auditory thalamic nuclei, called the medial geniculate nucleus. In addition to that, it's going to function as a relay nucleus for reflex responses to auditory and somatosensory stimuli. Within the inferior colliculus is going to be three subnuclei. There's going to be a central nucleus, a pericentral nucleus, and a external nucleus. The central nucleus is going to be the main nucleus that receives that binaural auditory input via the fibers of the lateral lemniscus. It is also going to receive bilateral input from the primary auditory cortices. And in this central nucleus, the low frequencies are going to be represented in the posterior lamellae, whereas high frequencies are going to be represented in the anterior portion. Note that this is backwards from the tonotopic organization of the ventral and dorsal cochlear nuclei. From here, the central nucleus is going to project to the medial geniculate nuclei. The pericentral nucleus is going to receive monaural input from the contralateral inferior colliculus via the commissure of the inferior colliculus. Its main job is to increase auditory attention and localization of sound. Its efferent projection is going to be to the central nucleus, which will project to the medial geniculate nucleus via the inferior brachium. The external nucleus is going to be located posterior to the central nucleus and lateral to the pericentral nucleus, and this nucleus is going to function as the center for the acoustico-motor reflexes, so auditory and somatosensory fibers will synapse here. So as stated before, the inferior colliculi are going to be considered the fourth order neurons of the auditory pathway. So these fourth order neurons are projecting to the medial geniculate nucleus, which is the auditory relay nucleus of the thalamus. So from the medial geniculate nucleus, these fibers are going to project to the transverse gyri of Heschel, which is Brodmann's area 41 in the temporal lobe. And I should add that this is happening on the side that is ipsilateral to the medial geniculate nucleus. So that's the auditory pathway. I would focus a lot on what's going to be ipsilateral and what's going to be contralateral, because that's going to be what's tricky on the exam. I would also make sure that I knew what was first order versus second order versus third order, and how it's explicitly stated in the course pack.